All right, class, let's talk about oligopolies. So here's the oligopoly graph. We're going to spend a lot of time looking at this graph. Um, and so I'll break it down part by part. So don't freak out if you don't understand it entirely right away. At the end, if you don't understand it, then maybe you should reach out to me and ask a few questions and we can hash out some things. That's why obviously I have my phone number there so that we can communicate if you have questions. So there's two graphs you can see here. Both of the oligopoly graph. This is the kind of the technically what's happening, but this is how they always show the oligopoly. So you have two graphs. If you notice here, we have D1 and D2. Demand 2 is your elastic demand, and D1 is your inelastic demand. And of course, you have the marginal revenue lines that go along with it. So you have your inelastic marginal revenue and your elastic marginal revenue. And so why do we have two different demand lines for oligopolies? Well, that's because the demand for your product will depend on your competitor, or maybe sometimes competitors. An oligopoly, again, is a few competitors. So depending on what they do will affect your demand. And so that's why you have the different demand lines. Now, something to point out here, the marginal cost lines in blue, those are hypothetical marginal cost lines. There's not two marginal cost lines for an oligopoly. There's always one marginal cost line for any company, but obviously those marginal costs can change. This is just showing some hypothetical marginal cost lines, and I'll explain more about that later. So don't get hung up by that. Now, why do we go from this to this? Well, because the elastic demand curve intersects the inelastic demand curve. And so in essence, we just make that one demand curve. We call it the kinked demand curve. And the marginal revenue is a similar thing. We have the elastic marginal revenue, and then they kind of intersect here with the demand, and then it switches to the inelastic demand. Therefore, we switch to the inelastic marginal revenue at that point. And so again, we'll explain more about this as we go along later. Now, do you recall what part of a normal demand curve is elastic? Is it the top part or the bottom part of the demand curve? Well, it should be easy to remember just visually here. And if we just remember, here's it is the top part of your demand curve is elastic. So it's always hopefully easy to remember the kink demand curve, the oligopoly demand curve, because the elastic portion is the top and the inelastic part is the bottom. And that's going to become really important as we continue to talk. So let me ask you, would you rather be, in general, what would you like to do if you're in the elastic part? What would you like to do with your prices? Do you want to raise your prices if you're in the elastic part? Or do you want to lower prices if you're in the inelastic part? The answer is you want to lower your prices, because as you lower prices, your total revenue will rise. Now, if you find yourself in the inelastic part, what do you want to do with prices? Do you want to lower them? No, total revenue will go down. You want to raise them, right? And so the sweet spot for total revenue is going to be in between. But so inelastic, you usually want to raise your prices. Elastic, you want to lower your prices. So this is in general. In oligopoly, it's still very much true, but on the inelastic part, there are some times when you actually might want to lower prices, and we'll explain that as we go along. Today, we want to focus on game theory. Before we do, though, I want to talk about one other thing. Because competitors in oligopolies are likely to not change their prices too much, and I'll explain why they don't change their prices too much. Oligopolies tend to have a lot of non-price competition, where they focus more on other things besides price. So They focus on the differences and innovation that they might have. They focus on the service they might provide along with their product. They focus on extra upgrades or the loyalty pro schemes and or branding or free shipping, other sales promotions. They do these things instead of focusing on the price of the product because you'll see later why they like to keep their prices stable. Um, and maybe you're getting some of it now, but you'll hopefully get more of it later on. But now let's move to, like I said, the game theory part. So we're going to talk about game theory, and if you want some more practice, I have some other video links after this one today that you can feel free to go and look at and practice with. So before we talk about some key terms, let's look at how do you read a game theory matrix. So first, the game theory, there are two competitors, two players, business Y and business X. Business Y can have sales, yes, or have no sales. Company X can have sales, yes, or no sales. And then down here, your A, B, C, D, E, F, G, H. These are the payoffs. And so depending on how a matrix is written out, there'll be points or money associated with each decision. And so in this case, if company Y or player Y says no to sales, they're going to get a payoff of E and G. We don't know what numbers are associated with that just yet, but that's how I read it. And of course, if they choose yes, they get payoffs A or C. Now, we figure out what Y will receive, what payoff they'll receive by what X decides. So if X and Y both decide yes, then Y will receive A and X will receive B. Now, if X decides no sales and Y decides to do sales, then Y will get a payoff C and X will get a payoff D. So that's an example of how you might read one payoff matrix. Let me show you another payoff matrix you might read. So here's another one. It looks a little different. This time we actually have numbers connected to things. So you have store B and store A. And so payoffs for store B are going to be 600 and 500 if they have no sale. Or they have periodic habitual sales. They'll get payoff 900 or 400. And of course, chain store A will have 300 and 700, 450 or 200. Again, all of these payoffs will depend on what the other person decides. So let's do this question together. And I'm going to put this Word document on the Canvas page for the day. And so you can feel free to look at this and look at the key that goes along with it and practice, because I have some other questions you can practice with here as well. But we're just going to focus on question 2 here today. So it says, don't try to make sense of why the daily payouts in this matrix are what they are. Yeah, don't usually always try to figure out the why, but just that they are. And then can you read the matrix and interpret it correctly? That's what we want to focus on. So the stores have to choose between operating with a policy of no special sales, called everyday low prices, or have a periodic and habitual ongoing special sale pricing. That'll be this guy right here. Now, if chain store A chooses to have habitual sales, so they're going to choose this choice. Is there a dependent dominant strategy for chain store B? So basically, we're going to pretend we're chain store B, and we know that chain store A is going to do habitual sales. So that means that we can either do no sales or we can have habitual sales. So if we do no sales, that's going to be 500 payoff profit or 400. So do we have, as it says, a dependent dominant strategy? Yes, we have a dependent dominant strategy. We are going to get $500. And by the way, if you want to see the key for this document, which I will share with you guys, is right below it. Yes, you can see. So anyways, so is there a dependent dominant strategy? The answer is yes, and it would be no sales because we get more profit. It's called a dependent dominant strategy because it's dependent on chain store A. Now, let's go back to our definitions for a second. Now, now that we're getting into how to read it. So we've got dominant strategy. Dominant strategy is the best choice for an individual, whether you know or if you don't know your opponent's choice. Dominant strategy gives a larger payout, so they're more profit. Dominant in mathematics technically means to have terms or components greater in absolute value than the corresponding terms of components of a given series, vector, etc. So it's not like it's the same as math, but it's similar. It's a greater payout, right? Now, Nash equilibrium, we'll get to that, and there'll be some more examples in the videos following, but it's to keep your dominant strategy when you know the choice of your opponent. And so we'll get to that more later in the other videos. But let's go back to our example. We have for question A, there is a dependent dominant strategy. We'll answer the question in a little bit. Does chain store B and A have dominant strategies without knowing what the other store is going to do? So let's go to question B though. If the two stores collude, is there a cell that beckons them? So collude is if they scheme up together and they say, hey, let's jack the prices up together, let's lower the prices, or let's keep one price high and one price low, and we'll both make the most profit. And so let's see here. For chain store B, they can get 900 or 400. They get 600 or 500. So obviously they're going to want to be in B. They'll make the most money there. Chain store A can have 300, 450, 700, or 200. The most that chain store A can make is 700. Same square as chain store B. It's the largest amount of money. So yeah, if they both colluded, chain store B would have habitual sales and chain store A would have no sales. They would both make the most profit. Now, the question C, though, is without collusion, which cell will they fall into? Now, let's think about this. Chain store B, 900 or 400, 600 or 500. Now, if chain store B chooses habitual sales, they could get 900, which is better than 600. But if chain store A chooses habitual sales, they'll get 400 if they choose habitual sales too, which is worse than if they did no sale price, 500. So what that means is that chain store B has no dominant strategy because in either case, they still, in either case, there is no dominant strategy because if they chose no sale, $600 is worse than 900. But if chain store A chooses habitual sales, 500 is better than 400. So in a sense, again, there's no dominant strategy here for chain store B. Let's look at chain store A. Chain store A, they could do 300 or 450. So if if we're just thinking about these two, they would choose to have habitual sales. But habitual sales, if it might be better in this circumstance, but down here, if chain store B chooses habitual sales, they only get 200, which is worse than 700. So in both chain store A and chain store B do not have a dominant strategy. A dominant strategy would be if they would choose habitual sales every time, no matter what chain store A did, because they would make the most profit. So back to question C, without collusion, which cell they fall into? Well, We don't know because they don't know the other person's going to. There's no dominant strategy. And so C, the key says no. Best choices all depend on the other business's choice. All right, now to D. If the malls where these chains are located offer a subsidy of $100 per day so that they have sales, which cells would change and by how much? So let's change our numbers here. $100 per day so that they have sales. So that would mean for sales, chain store B is now going to have 1,000, 800, 500, and 300. So the question asks, so the bottom cell, the bottom ones are going to change. And now question E says, now is there a dominant strategy for either of these chains? Well, now let's look at chain store B. You can have 1,000 or 600. Obviously, 1,000 is better, so you want to have habitual sales. And then with habitual sales, it's 500 or 500. Oh, both equal the same value in profit. So no matter what, chain store B is always better off having habitual sales. So chain store B now has a dominant strategy. It doesn't care what chain store A does. It's always going to have habitual sales. Now, chain store A, though, 300 or 450, well, 450 is better, but 300 is still worse than 800. So chain store A does not have a dominant strategy. It may have a dependent dominant strategy, but it does not have a dominant strategy. So the dominant strategy is chain store B will have habitual sales. So hopefully this helps you better understand what is how to read and what is game theory and how to find dominant strategies and things like that. Anyways, you can have more practice using this, looking at the other videos below the video today. All right, back to some definitions. And so these are some important terms you might need to know for the AP test. And so usually what I would do is I would give you, students, I'd make you in class, create some of your own payoff matrices. You'd even give me an opportunity to gain some extra credit, but sadly, not this time. So we're going to just move on now, and I'm going to explain how the payoff matrix connects to oligopolies. So let's look at this. We have Arch and we have competitor. What should Arch do? If Arch doesn't know what the competitor is going to do. And again, if we notice here, it's high or low prices. It could be, game theory can be anything. Tell the truth or lie, or take drugs or don't take drugs, or study for a test or don't study for a test. But in this case, with oligopolies, it's almost always high price or low price. Now, low price, they can $15 or $12, $8 or $6. So what's the dominant strategy? Well, 15 beats 12, 8 beats 6 every time. So Arch is going to have a dominant strategy of low prices. And the competitor, again, they can do 12 or 15. So 15 beats 12. They have 6 or 8. 8 beats 6. So the competitor is also going to have a dominant strategy of low. And so if both of these competitors aren't colluding, what cell are they going to end up in? D. They're going to end up in cell D. And they're going to sell their product for $8. Now, they're going to sell their product and get only $8 of profit. So that's not the best profit. What would they choose to do if they were to collude? If they're to organize? Well, they could both charge high prices, and then they would both get $12 each. in profit, which is a pretty good deal. So why don't all oligopolies just collude? Well, there's a couple different reasons for a couple different answers to that question, but here's one. What happens if they both decide to collude and then eventually one competitor says, all right, that's it, I'm done colluding, and the other person is still stuck at a high price? Let's say Arch decides to collude and then bring down the price to low. Well, look, they would get $15, even bigger than 12, and the other competitor would only get 6. And so if there is collusion, there's a lot of incentive to break the collusion. And so in both situations, both competitor and Arch, there's a lot of incentive to break collusion. Hence why you don't always see collusion in a lot of real world scenarios. So in real world, in the graph, you see they're going to want to lower, keep prices low. Again, if you think about it, the elastic portion of their demand curve, they're going to have more total revenue if they lower prices. They will talk about in this part how they might want to lower prices as well. But now, why is there price inflexibility? So let's start to break down this graph. And I'll explain some more why there's price inflexibility tomorrow, and why sometimes in the inelastic portion of your demand curve, why people want to lower prices or sometimes raise prices. And we'll explain more about the marginal costs tomorrow. Stay tuned. Peace.